Hey everyone, my name is Kanaya Gupta and welcome to my YouTube channel. And today I am going to talk about the techniques which can help you to solve any dynamic programming problems. Before moving ahead, make sure you are subscribed to my channel and click the bell icon so that you don't miss any update. Let's start. Technique to solve DP problems. To solve any kind of DP problems, we can use the FAST method. What is the FAST method, guys? Here F stands for find the recursive solution. So whenever you see any DP problem, you have to find the recursive solution of that problem. A stands for analyze the solution. Here you have to analyze your solution. Once you are able to come up with a recursive solution, you have to analyze your solution and look for overlapping problems. As we know, DP can be applied only on overlapping problems. These are the characteristics of the DP problem. So definitely there will be some overlapping subproblems. So you have to look for those. Once you are able to identify, then we'll move to the third step, which is S. Means save the results for future. So now you know the problems are overlapping problems. So what you are going to do, you are going to save those problems so that you don't need to calculate again and again. So you are going to save the solution of those problems. Once you have solved that problem, save that problem result into some storage so that in the future, if you require, you can get it from there. So basically here you are going to use the caching. So use n-dimensional array for caching purpose. So this is the third step. So if you have followed F, A and S FAST technique, then you have done with the dynamic programming. But this technique is known as top-down approach. If you are able to achieve F, A and S, that means you have applied the top-down approach to solve the problem. But still it's not pure DP. So let's move on to the next one, which is now you have to tweak the solution to make it more powerful by eliminating recursion overhead. So if you are able to remove the recursion, manage to come up with a solution which is an iterative approach, then it becomes the pure DP solution, which is also called bottom-up approach. When you use recursion, this is a top-down approach. When you remove that recursion and able to perform the same stuff with the iterative approach, this is called bottom-up approach. So if you are able to apply T, which is a tweak the solution, that means it's a pure DP solution. Because recursion is always an overhead on your program. So try to achieve that T. If you have achieved up to S, FAS, and it's still a DP solution, but it's a top-down approach, which generally people don't prefer just because it consumes a lot of memory and there's a lot of chances you will get stack overflow error because of the recursion. So try to come up with the bottom-up approach always. If it's not possible, then top-down approach is also fine. So these are the 4 steps which you need to perform on any problem so that you can get the result. So guys, this is the 4 concise steps which you need to perform, and these 4 steps is help you to solve your DP problem. If you are not able to remember, that is why I have given a name as a FAST. So just remember the FAST method and you will be able to visualize what F stands for, find the recursive solution, A stands for analyze the solution, S stands for save the result for future, and T stands for tweak the solution in a bottom-up manner. Now I'll take up one problem and we'll follow all those steps and I'll show you how I have done it. Let's move ahead. So here the problem statement is write an efficient program to find nth Fibonacci number. So this is a problem statement, guys, and we know the Fibonacci series looks something like this, right? 0, 1, 1, 2, 3, 5, 8, 13, 21. So now the first step is, guys, these steps you can only perform once you are sure your problem is DP problem. So here I am going to show you the techniques to solve DP problem. It's not at all to identify the DP problem, it's all about the solve DP problem. So if you are watching this video, it means the problem, whatever you are doing, you are sure it's a DP problem, right? So this question, I know this is a DP problem. So now apply the first step, find the recursive solution. How you are going to find the recursive solution from this, guys? you have to come up with some solution or maybe a recurrent solution which will look something like this. If you see this recurrent solution, it's very easy. If n is less than 2, then return n. Otherwise, return fib n minus 1 plus fib n minus 2. So if you want to calculate Fibonacci number for nth term, you can use this recurrent solution or this formula. So this is a mathematical definition of a solution of Fibonacci number. Now the same thing you have to translate it into your code, which will look something like this. So if you see whatever I just said and whatever we have wrote in a mathematical formula, the same thing I have written over there. If n is less than 2, return n. Else, instead of otherwise, here we are using else, return fib of n minus 1 plus fib of n minus 2. Right? The first step is this: find the recurrent solution or the recursive mathematical formula and then translate it into code. Once you are able to achieve this, then we'll move to the next one. But for now, if you see, if you use this approach, and here also this solution, whatever is there, this is also a working solution. If you use this in your programming language, it will work, definitely work. But the complexity of this solution will be too much. And the complexity of this solution will be 2 raised to the power n. Right? That is the reason we are looking for the dynamic programming, because that will reduce this complexity from exponential to the polynomial type. For those who have not watched my previous video on the theoretical concepts, please watch this video which is mentioned in the top right corner to get the more understanding about it. So guys, here the complexity is 2 raised to power n if you use direct recursion, right? But we are not going to use it because we need to optimize this problem. That's why we are using the DP technique. So now we have done with the first step. Now the second step was analyze the solution. Let's go and try to analyze the solution. If you want to analyze the solution, and if you remember what was the reconciliation or the mathematical formula, we can easily see if you want to calculate fib of 4, it's depend on fib of 3 and fib of 2. And if you want to calculate fib of 3, it depends on fib of 2 and fib of 1. In the same way, fib of 2 depend on fib of 1 and 0. If you see this, you can identify here for calculating the fib of 4, you need fib of 3 and 2. And for calculating fib of 3 also, you need fib of 2. So basically here fib of 2 is an overlap, because for calculating the fib of 4, you need to calculate fib of 2. And when you are calculating fib of 3, at that time also you need to calculate fib of 2. So it's an overlapping problem. In the similar way, this is also an overlap, or the same can be visualized here. Now we are sure that it's a overlapping problems. So what is the next step? We have to save the results. So the third step is save the result, and this technique is also called memoization. So guys, please make sure you are not making a mistake here. It's not a memorization, it's a memoization. Okay. So in that, we are going to use the same recursive approach, whatever we have just wrote in a couple of slides before. And here we have just introduced our cache mechanism. So now we have taken one array of n plus 1 size, and we are using this cache to return the result. First we will look into the cache. If cache is not defined or is not equal to 0, then we are returning the result from the cache onwards. Else we will calculate the result and put into the cache and return the same. So this technique is known as top-down, guys, because it's a recursive approach. And here we always look first in the cache. So it's like cache will be populated on demand basis. If you want to calculate the fib of 4, we will see if in cache fib of 4 is there or not. If it's there, we will return the result. If it's not there, we'll make a call to 3 and 2. And we'll do the same for 3 and 2 also. If fib of 3 is already there, we will return the result. If it's not there, then make a call down. Right? So in the same way, it's like when you want to calculate fib of 4, we'll see if already result is there from the cache, we'll return. Otherwise, we'll go till the bottom and calculate and return. That's why it's called top-down approach. First we'll look for the top. If it's there, just return the result. If it's not there, just calculate it and save into the cache and return the same. Now this solution has a complexity of O(n), and because we are using the extra space, the space complexity is also O(n). So here we are not going to solve the same problem again and again. We have already solved the problem once. We are storing that result into our cache. That's why we have space complexity of O(n). So now we have solved this problem by using top-down approach. So now we are on third step, which is S, save the result. So we have achieved fast here so far, guys. So this is also a DP solution, but using the top-down approach, which people generally don't prefer because recursion is involved here. So now we have to move further and tweak this solution in a bottom-up manner and remove the recursion. So in this step, we are going to tweak the solution. How we are going to tweak the solution? Now we are going to remove the complete recursion from this solution and make it iterative. So this is a solution, guys, where we have the same cache with the n+1 size, and instead of recursive call, here we have placed with the for loop, and which will go from 2 to n. So if you see, if you want to calculate Fibonacci number for a particular number, right? So first we will populate the cache, and from the cache we will return the result. So the loop is going from 2 to n. So it means first we'll calculate 2, then we'll calculate 3. So it's like incremental step. So we are going from down to up, or we can say from bottom to up. So which can be visualized in this diagram. So we already know Fib1 and Fib0 value. So now first we'll calculate the 2. Then once we calculate the 2, like that we are going to populate the same 2 and then 3, then 4. So here we are going from bottom to up. We are populating the cache from bottom to up. That's why it's called bottom approach. And here there is no recursion at all. That's why this approach is much more efficient than the previous one. But the complexity is same, guys. So here the complexity of the solution also is O(n), time complexity and space complexity O(n), because still we are using the cache. So if you are able to achieve this T, so it means now we have followed the complete method, which is a fast method. And this solution is a pure DP solution if you are able to apply or tweak your solution to a bottom-up manner. So this is the final solution, guys, which we are looking for. So if you get any problem on DP, you have to follow the same 4 steps and you will be able to achieve your destination, means the bottom approach DP solution. So I hope, guys, now you have clear what is DP, what is top-down approach, and what is bottom-up approach, and which one is a pure DP solution. So this is a pure DP solution which interviewer is looking for it. So make sure whenever you write a DP solution, you always write a bottom-up approach, because whenever you write a top-down approach, the interviewer can still ask that recursion is overhead, how you will going to improve it. So you should know the iterative approach also. But one thing you have to notice, right, there is no guarantee that DP is always a optimal solution for a problem. For this, in this case, you can see, you maybe think of this is an optimal solution which we have got so far, but this is not the optimized at all. There's a still scope of improvement in this solution, and I will show you right now. Now I am going to show you the efficient solution for this problem. If you see this problem clearly, you can easily say from the series, every element or the every term in a Fibonacci number is totally dependent on the previous 2 numbers. If you add those 2 numbers, you will get the next term. So if you see in the series, if you add 0 and 1, you will get the third term. So in the same way, to get the next term, you have to add previous 2 terms, right? So if you clearly identify, you can come up with this solution. So in this solution, there is no recursion. There is no array also for caching purpose. What we have done, we are taking a tree variable first, second and sum. First and second is already predefined because 0, 1 is there and sum is 0. So like in all the solution, we have did the same thing. If n is less than 2, return n. Else we'll go into the loop and we'll calculate the third term. Third term is sum here. So we'll calculate the sum of first plus second, so that you will get the next term. So once you get the next term, for the next iteration, now that term will be act as a previous two terms. So we are just swapping, we are making second term as a first term and the sum as a second term for the next iteration. So in the same way, you will get two terms, and once we sum up again, you will get the next term. So if you use this technique here, basically we are not storing the all previous terms. We are only storing two terms, which are previous two terms in first and second. And these are the temporary storage, because we know once we achieve the next term, the last two terms is not at all useful. So we always look for the two terms, which is the immediate previous two terms, and we'll carry forward those things. So this is the efficient solution, guys, among all. And the complexity of this solution is O(n), and the space complexity is O1, because here we are not using any extra space, which we are using in other techniques. So this is the efficient solution, guys. I just wanted to show you this example so that you will have a clarity that programming solution is not always the optimal one. There may be a chances if you can come up with such kind of approach which will solve your problem more quicker than the DB solution. So guys, I hope all those stuff is clear to you. If you find it useful, please like, comment, share and subscribe, guys. Let's move on to the demo part where I will show you how all those solution affect and how much time it will take. Let's start. So I have coded all the solution, guys. I have showed you 4 solutions so far. So this is the first solution. So I have mentioned the method 1, fib method 1. So here we have used a pure recursive approach, which will take 2 raised to the power n time to calculate the Fibonacci number, which we have already seen. And the second method is like top-down approach. And this is a method 2, guys, where we have used the cache mechanism, but it's a top-down approach because we are using the recursion. And the third method is iterative approach, which is also called as a bottom-up approach, where we are not using recursion at all. So this is the method 3rd, guys. And the code is same, guys, which I have shown you on the slides. And this is the final efficient approach. This is also we have seen. So we have 4 different approaches to solve this problem. So I am calling all those 4 methods, and each and every method will print the result and the execution time, how much it has taken. So we'll calculate the fib of 4 from all the methods because we have used fib of 4 a lot. So now I'm passing 4 here and we'll see what is the result. So guys, if you see the execution time of method 1, which is a totally recursive, will take this much of nanoseconds. Guys, these times are in a nanoseconds. Okay, because for 4 it will take very less time, but I'll show you the difference. So method 1, which is a totally recursive, is taking this much nanosecond, and the result is 3. We know the fib of 4 is equals to 3. And method 2 has taken these many nanosecond, and method 3 has taken these many, and method 4 is taken this. Guys, here it's showing more than this, but I think there is some issue, or sometimes it's behave abnormal, or maybe we'll run this program again. Yeah, guys. So if you see this time, this has taken less time. So there may be some time to getting a resources and all, as these times are nanosecond. But once you do the calculation for a longer range, or maybe for the higher value of n, you will see the actual differences. But still you can see the differences in the nanosecond, right? So just to show you guys, you can see the graph is going downward. So this is the more optimized solution for the Fibonacci problem. I hope you got this idea, guys. If you have not subscribed this channel yet, please subscribe and click the bell icon for more updates. Thanks for watching, guys.